All right, guys, today we're starting chapter 5. Chapter 5 is a pretty lengthy chapter, it has lots of sections in it. And so we'll actually be in chapter 5 until Christmas break. That seems like a long time away, but remember, we got a week off for, almost a week off of Thanksgiving, and it's kind of right in the middle of that. So, but we'll be finishing up right before Christmas. Yes. So lengthier chapter. I don't think it's a very difficult chapter, although there's a lot of stuff in this chapter that is new. Last chapter, inequalities, it was a lot like the equations chapter we did. It was almost exactly a repeat other than the flipping the sign stuff that we had to do and the graphing. This one's going to have some new stuff in it. Today, we're going to talk about ratios and rates. And so to start with, I'm going to read off a description to you guys, and I want you to tell me which of these 4 verbal rates you would expect to hear back if I asked you for example, your running rate in a 100-meter dash. What kind of rate would you expect someone to say, hey, coach, what was my running rate? What are they going to tell you, Natalie? Yeah, they're going to say something meters per second. You know, and of course in track, for those of you who do track, you know that everything's measured in meters on those tracks. So meters per second, that would make sense. What about the next one, the fertilization rate for an apple orchard? I'm buying fertilizer. All right, Izzy? That's right, pounds per acre. You buy so many pounds of fertilizer per acre. Next one, the average pay rate of a professional athlete. Gage? Dollars per year. That'd be that pay rate of anybody, but yeah, for a professional athlete. And the last one, the average rainfall in a rainforest. Aaliyah?
Rudy, please come to the office.
Inches per year.
Miles, Rudy, your lunch is in the office.
Go tell the people at lunch he's not down here. All of these in the right column there are called rates. And the interesting thing about rates is that they all have 2 labels. If you said that a professional athlete made $5 million, I would need more context. Was that in a year? Was that for their entire career? Did they make $5 million last night at the basketball game? Like, I would need to know $5 million per year.
Please come to the office.
Gosh. Same with the meters per second. If you said, coach, how fast did I run? You said, 60 meters. Okay, thank you. I know that. Okay, in fact, it's 100 meters. How fast did I run? Like, you need more context. Meters per second would give you that speed. Okay, you guys talked about rates in science class. You haven't done the speed, distance, time pyramid thing that Mrs. Coulson does. You haven't done that yet? Okay, never mind then. Okay. All right, well, we'll go on to our first vocab word of this chapter, which is ratio. And a ratio is a comparison of 2 quantities using division. That is going to be really important here in a second, division. A comparison of 2 quantities. There are 3 ways that you can write ratios. You can write them as fractions. Most people write them as fractions. Every time you've written a fraction, you've written a ratio. You can write it with the word 2 between them, because that's actually what a ratio is. You would say 3 to 4, 3 to 4, or you can write it with what's called a colon, and that colon's got 2 dots right there. So each of those are ways that you can write ratios. Now, I don't know what it is we're referring to when I say 3 to 4. Is it 3 cups of milk for every 4 cups of flour? Is it 3 bananas for every 4 oranges? I don't know. And that's why our next definition is a little bit nicer, because it's called a rate. And a rate is a ratio that has different labels. So if you take those two numbers and you put labels next to them, for example, instead of just 60 to 2, it's actually 60 miles for every 2 hours. That became a rate because it has a label. So that's what a rate looks like. Now, if you were telling me how fast you went, would you say that you were going 60 miles every 2 hours? Is that what you would say? 60 miles per 2 hours? What would you say, Gage? 30 miles per hour. Exactly. So the last definition we have here is probably the most important one, a unit rate. A unit rate is a rate with a denominator of 1. A rate with a denominator of 1. So what Gage did to get 30 is he was able to reduce this fraction. 60 over 2 reduces to 30 over 1, which is what you see down here. And even then, 30 over 1, that just reduces to 30. Wouldn't you hear someone say 30 miles per hour more often than you hear someone say 60 miles per 2 hours? I don't hear anybody say that, 60 miles per 2 hours. So 30 miles per hour for each hour. So a unit rate is a rate in which that bottom or second label is singular. Do you know what singular means? Frank? Just one. Yeah. So miles per hour, miles per gallon, students per teacher. Okay. Price per ounce. The second label is always singular. Okay, Aaron, you're not paying attention back there. I can tell. We talked about this already, about focusing. To find a unit rate, divide. To find a unit rate, divide the numbers and the labels. The labels, what is that supposed to mean? Well, Gage, when you did 60 divided by 2, you got 30, right? Well, 30 has to be labeled. So what do you label it as? You can't say 30 miles. That's not true. You went 60 miles. You can't say 30 hours. You only drove for 2 hours. But you can say 30 miles per hour. And the way that we abbreviate the word per is by putting a slash. 30 miles per hour would be written like this. Now, if you wrote it as MPH, I would accept that. MPH is a very common abbreviation for miles per hour, but not every ratio can be, or every unit rate can be labeled like that. So if I was doing students per teacher and someone labeled that SPT, I've got no idea what that means, right? So MPH, that's all right. MPG, what's MPG stand for? Miles per gallon. Okay, that's a pretty popular one too. STP, no one outside this classroom is going to know that STP stands for students per teacher. Okay, so with your other rates, I'm okay if you abbreviate them, but you need to put the slash between them so we can see both words. Okay, this is going to be your struggle this chapter because some of you are still struggling right now just to label any story problem at all. These story problems have to have 2 labels. Okay, miles is a distance. Hours is a time. But if you say miles per hour, now it's a speed. And that's why we need 2, because that's a rate. Okay? So we're going to divide the numbers and the labels. Why are unit rates helpful? Well, here are 2 unit rates. Assuming that all the equipment at both of these snorkel rentals is the same, would you go with the orange snorkel or the red snorkels, Gage? Why? Yeah, it's cheaper. You're going to pay quite a bit less per hour. And that is a unit rate because hour is singular, dollars per hour. Now, if they would have said, if I take 725, let's say I times it by 9. Let's say that you're going to pay $65.25 for every 9 hours. Okay. How much is that per hour though? Like you kind of want to know that. Unit rates are helpful because you're able to compare them with other unit rates. Whereas this one said, you're going to pay $65.25. I can't really read that, can you? For 9 hours. And the other one says, well, you're going to pay $35 for me for 4 hours. It might look like the orange one's the better deal, but actually $35 divided by 4 gives you $8.75 per hour. And 65.25 divided by 9, that gives you 7.25 per hour. So actually still the red snorkels are better. And so that's why we like unit rates, because it makes it very easy to compare. There's no misconceptions. All right. So how do you find a unit rate? Divide. How many of you guys are in my extension class? Okay, do you remember Monday's IXL was all about dividing? That's what we're doing. Yeah, we're just going to divide, which makes sense because especially if you write a ratio as a fraction, what's that little fraction bar tell you to do? Exactly. Yep. So you read this as 60 miles in 2 hours. I read that as 60 miles divided by 2 hours, which is 30 miles per hour. Okay. So let's do some ratios first. There are 45 males and 60 females in a subway car. The subway car travels 2.5 miles in 5 minutes. We'll come to that, the speed there here in a little bit. Let's first write a ratio of males to females. Now remember, there's 3 ways you can write a ratio. You can write it as a fraction, you can put the word 2 between it, or you can use the colon. Gage, what do you want to do? Okay, so write as a fraction, 45 over 60. That's probably the most common way of doing it. But there are people that prefer to write their ratios as, I guess, like this, using the colon. Now let's look at our fraction answer that Gage gave us. That was the males to females, 45 males, 60 females. What's wrong with that fraction? It can what?
No.
It's not improper.
It can be simplified.
It can be simplified. Remember, improper means the bigger numbers on top, which is actually okay with ratios. It's okay if they're like that, but they do need to be simplified. Oh, and by the way, what did you do on your chapter 5 opener?
Simplify.
Well, those of you that have done it,
Simplify.
if you haven't done it yet, you definitely are going to be simplifying fractions on that chapter 5 opener. That's why there's no work paper, because you don't have to show your work. Now, what you would do on your work paper for tonight's homework, you'd write this ratio down, and then you'd write what it equals. What's the biggest number that goes into 45? That also goes into 60? 5 works. 15 is better. 15 is better because I'm looking for that greatest common factor, so I don't have to do as much reducing. So if I divide by 15, which you would not have to write divide by 15 down, but I'm just going to show you, remind you what we're dividing by. How many times does 15 go into 45? 3. And how many times does it go into 60? 4. That's the ratio I want. I don't want 45 to 60. I know that's the numbers, 45 males, 60 females, but that means there's 3 males for every 4 females. And if you give me this answer, I'll accept it, but you have to reduce that too. So it'd have to look like this. Yeah, you can't leave it as 45.60. You can't, you have to reduce that. Even though it's not in fraction form, it still has to be reduced. What about the ratio of females to total passengers? Calvin, how many females are there again? What about total passengers? That's right. There's 105 total if you add the males and females together. So 105 total passengers, and that fraction can also be reduced. What's a number that goes into 60 that goes into 105? Is it 15 again? Double check for me. Does 15 go into, I know it goes into 60 because we just did that. Does 15 go into 105? And if so, how many times? 7 times? So that ratio reduces to 4 to 7. 4 females for every 7 passengers. Now, if you didn't see that 15 went in there and you just were going to take out the 5, that's okay. If you reduce by 5, you get 12 over 21. But you know what? That reduces. What goes into 12 that goes into 21? 3. And so what's 5 times 3? 15. That's why the 15 works, because 5 and 3 both went in. And so, yeah, if you reduce by 3, you end up getting 4 sevenths there. Okay, so make sure you're giving the most reduced fraction when you're reducing your ratios. You know, we probably could have saved ourselves a ton of work if we just would have paid more attention to the last problem. If there's 3 males for every 4 females, what's 3 plus 4? 3 plus 4. And that's, isn't that 7 total people in this ratio? What's our fraction out of? 7. Yeah, we could have saved ourselves. We could have said, well, if there's 3 males for every 4 females, that's 4 females for all 7 people. Yeah, so that would have saved us a little bit of time. Now, the last part here for this example is finding the unit rate and a speed. Speed is a unit rate, and it wants the speed of the subway car. So let's go back up to where it gives us the miles and the minutes. Would it make more sense to write our answer in miles per minute or minutes per mile? Miles per minute. That's pretty typical because when you're talking about speed, you usually in fact, almost always write the distance number first and then the time, miles per hour, distance time, meters per second, distance time. So my distance number is 2.5 miles. Go ahead and write that down here. 2.5 miles. I abbreviate miles, MI. You can't just put M because what's the M stand for? Meters. And I'm doing miles. So MI for miles. And then on the bottom of my ratio, my rate is going to be my time unit. You went 2.5 miles in how many minutes? 5 minutes. Okay, that's my rate. It's not a unit rate. To make it a unit rate, what do? I was surprised that all 19 of you didn't just shout that out at one time. Did we not say that just a few minutes ago? Divide, right? Yeah, to find a unit rate, you divide the numbers and then you label by also dividing the labels. So if you're not sure what I mean by dividing the labels, right there's my label, mile/min. You just can't forget them. You can't forget to label it miles per minute. You can't forget that. So you take that division bar, you can divide numbers, so that's no problem, but you can't divide words. So the way that you do that is you just turn that fraction into a slash and you write miles per minute. Now, what is 2.5 divided by 5, Natalie? You did 5, you did it bottom divided by top. I did top divided by bottom. Frank? It is 0.5, that's right. 0.5 miles per minute. So half a mile every minute. Half a mile every minute. How fast is that in miles per hour? Yes, nice job. That's 30 miles per hour. I feel like we're getting a lot of the same answers we got with these ratios up here. 3/4, we use that for the boys to girl ratio in the subway car. The subway is going 30 miles per hour, but that's okay. We'll say half a mile per minute. That's okay. Gage?
I'll say, would you put up there for anything?
I would go ahead and write it like this. Miles per hour is one that's very common. MPM is not very common. Yeah, MPH and MPG are really the only two I'd let you write those as. Other than that, just go ahead and put the slash and write that. Abbreviate, but still write it out. Frank? Yes. So what have we learned so far? Hopefully we have this down. All ratios must be reduced. Otherwise, it will count them wrong. All rates must be labeled properly. Otherwise, I'll count them wrong. So on your work paper today, when you get a problem that says you went 180 miles in 3 hours and you find the unit rate, okay, you better not be putting 60 down without a label. Okay, what would the label for this one be? Miles per hour. Yeah, gotta have both. Can't say miles, can't say hours, but you can say miles per hour. Let's look at this ratio table. It shows the cost for 4 different amounts of artificial turf. This would be cheap artificial turf. Find the unit rate in dollars per square foot. Now, when it says find the unit rate, what operation does that mean we're gonna do? What operation are we doing? You just shouted it. Divide. Yeah, we're gonna divide. And then they tell you the order in which they want you to divide. They want you to do dollars divided by square feet. So as I'm writing out my division problem right here, there's my division bar. I'm going to put the dollars number on top. And I'm going to put the square feet number on bottom. Now the abbreviation for square feet looks like this. You might remember writing those last year when you did area problems. So in the problem, it's giving me the instructions for the order in which I need to divide these numbers. And that order is important because it's a little different when I look at this chart. What's the top number on all these on this chart? Gage? They are being multiplied by 4, but what is the top number measured in? What's the units of the top number? Square feet. Well, I need that to be the bottom. That's why I have to look to see what order they want me to divide it in. So Navion, why don't you pick one of these 4 ratios? You can pick the first one, the second one, the third one, or the fourth one. I don't care. Which one do you like? The first one, okay. Navion, which of those numbers is the dollar number? No. It says right here in green.
Oh,
It's the 100. Yeah. So you're going to pay $100 for 25 square feet of artificial turf. Great to know. But how much am I paying for each square foot? That's what we're going to find. What's this bar right here tell us to do? Divide. Davion, what's 100 divided by 25? Four. That's right. 4. And then what's my label going to be? $4 per square foot. Because that now it's singular, right? Because we just made it a unit, right? Now don't write it like I did. Don't put the $ behind the number. Every other label goes behind the number. The $ is the only one that goes in front of the number. So it should look like this. I'm still labeling it. I just want to move my $ so it's in front of the 4. So it looks like $4 per square foot. Now, by the way, look down on the ground right now. Each of those tiles is a square foot. Each of those tiles, if it was cheap artificial turf, would cost $4. How many tiles do you think is in this room? Over 100, more than 200. Probably between 2 to 3 to 400, somewhere in that range, probably 2 to 300. Okay. Now, how many tiles do you think there would be on a football field?
like 4 million.
Not millions. More than 1,000. Less than 500,000. Lots, right? And that's, if you're wondering why we don't have artificial turf on our football or softball, yeah, and this is cheap turf, very expensive. And so it's like, oh, that doesn't sound like much, $4 per square foot, until you realize how much you're getting for your $4 and how many of those $4 square foot you need, right? Okay, now, what if Navion would have picked one of the other ratios? Let's say he picks the second ratio. Does Navion still get 4 when he divides 400 by 100? Yeah. In fact, any of these ratios, I'm not ready to take it away. Put it up or I'll take it away. Each of these ratios, if you divide the $ number, which is the bottom one, by the square feet number, which is the top one, all of them are going to give you 4. So you could pick any one that you wanted to. I like the one that Navion chose because I can do 100 divided by 25 in my head. I know there's 4 quarters in a dollar. Let's move on to the next one. The table shows the amount of money you can raise by working concession stands at a school basketball game. Find the unit rate. Okay, well, for a basketball game, would it make more sense? This one doesn't give you the instructions. So you tell me, would it make more sense to tell someone that they made this many hours per dollar, or they made this many dollars per hour? Dollars per hour makes more sense. Okay, so like the last one, we're going to have to invert this. Dollars should be going on top of our division problem. And hours should be going on bottom of our division problem. Hunter, choose one of these 4 ratios. Okay, which one's the dollar amount number? Okay, that goes on top. And that means the 6 hours goes on bottom. Hunter, do 90 divided by 6 for me, please. $15 and label it. 15 what? Dollars per hour. Can we at least all label it? Does it make sense how we get the label? If you're not sure how to label it, right there, dollars / hours. Dollars per hour. Okay. So you divide the numbers and then you divide the labels. You put the slash between them. Nice if I could get that to erase. There we go. Natalie Dominguez, would you do me a favor and take 360 and divide it by 24? I wonder what she's going to get. Probably something different, right? What'd you get, Natalie? Oh, it's the same. Right? Any of these would give you the same number, right? They're all consistent. They're all what we call proportional. If I work more hours, I make more money, right? So if I work 24 hours and make $360, I'm making $15 an hour. And if I work 6 hours to make $90, I'm still making $15 per hour. Okay, right? Yes, yeah, with the magic squares, you could pick whatever one you want to. I see what you're saying. Yep. All right, next one. A complex fraction has at least one fraction in the numerator, the denominator, or both. So here's my best description of what a complex fraction looks like. It's a fraction within a fraction. It's a fraction within a fraction. That's a complex fraction. But it wants me to find the unit rate. And what am I supposed to do when I find unit rates? Looking for a one-word answer here. Frank? Divide. Thank you. So
When I was in third grade, I asked if you could put fractions inside fractions, and they had no clue what I was talking about.
you were talking about complex fractions. Now, the answer to that is no. We're not going to leave it like that. We're going to write it as a unit rate. And when we are done writing it as a unit rate, there won't be a complex fraction anymore. Okay, so if unit rate means to divide, shouldn't I divide like I did all the other ones? What's my top number? 1/2. What's my bottom number? 4. Can I write 4 as 4 over 2? Can I? What do I write 4 as? 4 over 1. Now, how do I divide fractions? Keep, change, flip. Okay, so this is now 1/2 times 1/4. Am I doing anything we haven't done before? We did this a couple chapters ago, didn't we? Yeah, I'm doing the same thing. It's just I'm not using my calculator. I'm using my fraction rules. And so what cancels when I multiply these two fractions together? Nothing. What's 1 times 1? What's 2 times 4? So now I get 1/8, and then C stands for cup per fluid ounce. 1/8 cup for each fluid ounce. You don't like using fractions? Okay, so what's 1/2 as a decimal? 0.5. Okay, so 0.5 divided by 4. I could do that, couldn't I? 0.5, does that give me 1/8? Oh no, it gives me 0.125. Which is the decimal version of 1/8. You get the same answer. I'll accept either one. As long as you label it cups per fluid ounce and not fluid ounces per cup. Make sure you label it the same way they had it mentioned there. C/FLOZ. Right, Taylor? Okay. Let's look at another subway car. Find the speed, unit rate, in miles per minute. Okay, so again, they're giving you the instructions. Remember last time we said it sounded better, miles per minute? Here they're saying it's miles per minute. Compare the speed to your first subway car that we did with the 45 boys and the 60 girls on it. So what's different about this unit rate is instead of just giving you the numbers, they're giving you a graph. They give you 3 points on the graph. One of them you're not allowed to use. Which one do you think you're not allowed to use? Gage? No, you can use that one. The 0, 0. You cannot use this point. You know why you can't use it? Don't unit rates mean to divide? And what happens when you divide by 0? What is the answer if you divide by 0? Undefined. So you cannot use that point, but you can use any other point on the line to find your unit rate. I like using this point here. I want to use that point. Okay, so for your first blank there, it says choose the point. We just chose 3, 1 and 1/2. And then it says find the speed. Now speed is distance over time. Gage, you have a question?
Why all the others said that that's not undefined?
No, it really is. If you divide by 0, it's undefined. If you have 0 on top, though, you can still get 0. As long as you're not dividing by 0. 0 can't be the second number. Which axis, the x-axis or the y-axis, is your distance axis? The y. And what is it measured in, Maddox? What is the y-axis measured in? Miles. So my y-coordinate, you guys remember plotting points last year? My y-coordinate is the second one here, is 1.5. So when it says 1.5, that's my distance of 1 point. You guys okay if I call it 1.5? miles. You guys like using your calculators, right? Okay. Now, the x coordinate is the time axis in minutes. What's our x coordinate at that point? 3. So the subway car travels 1.5 miles every 3 minutes. How do I find unit rates? Division. Calvin, what's 1.5 divided by 3? It's 0.5. And then we're going to put miles, just miles per minute. Miles per minute, that's right. Compare that to the first subway car. Okay, scroll back up here. Where was our last subway car? There it is. Oh, it was the same. So traveling 2.5 miles in 5 minutes is the same speed as traveling 1.5 miles in 3 minutes. Either way, you're still traveling half mile per minute, which Joe told us was 30 miles per hour. Right? Okay, use the point you didn't use to find the speed. All right, so that means we have to use, oh no, this point here, which was here. So remember our distance, we're doing distance by time. Our distance was the y coordinate, which was 1/4, and our x was our time coordinate in minutes, which was the 1/2. Now, I can still use decimals. What's 1/4 as a decimal? 0.25. So we'll say 0.25 miles in half a minute. What's half as a decimal? 0.5. Whitney, what's 0.25 divided by 0.5? Interesting that it's the same, or is that interesting at all? Do you remember when we had the ratio charts? Didn't I say you could use any ratio on the chart to get your answer? Doesn't it make sense that if they give me a line with a bunch of points on it, that I could use any point on the line, except which one? Can't use 0, 0. Now, is there other points on that line that we could use that they didn't highlight? What about this nice looking one right there? If I travel 3 miles in 6 minutes, guess what that's going to give me? 0.5, half a mile per minute. What about this point here? Can I use the 0.55? Is 5 divided by 5 0.5? What's 5 divided by 5? Why did I get something different? Yes, it's not on the line, right? It's got to be on the line. If it's not on the line, it's not going to be one of those equivalent points. Okay. So did your answer change? No, it did not change because your subway car is traveling at a constant speed. That's why it made a line. If it was traveling at different speeds, you see your line go like this. We don't call that a line, we call it a curve. Because it's a line, we know it's going at a constant speed, so any of those points on the line works. Last one. The graph shows the distance that you walk. Find your rate and, oh, they gave us the order, feet per second. Which axis is the feet axis? The y-axis, okay? Which axis is the seconds axis? Okay, so using one of the 2 points, not the origin, which of those 2 points do you like better? You like 4 and 22 better? All right, I heard it first. Hey, you had your chance. Which of those is the feet coordinate? 22, because remember it's the y. The y-axis, right, is the feet, and you can see 22 is actually right there. That makes sense. That makes the 4 the seconds number, right? So if I'm doing feet per second, that means I need to write 22 on top, 22 feet, and then 4 seconds. Do you remember on the charts how we had to invert them? Flip it upside down? We're kind of doing the same thing. We have to take the y and put it on top. The x has to go on bottom. Otherwise, we're going to do seconds per foot, and nobody wants to know that. What is 22 divided by 4? Natalie? 5.5. And how do I label it? feet per second. Elena, I haven't heard a lot from you today. I think Elena wanted to use this point. If you would have used this point, Elena, can you tell me what 11 divided by 2 is? Time, yeah, you times 11 divided by 2. What is that? It's 5.5, you say. What if I use whatever this point is right there? Do you think I'd get 5.5? Any point on that line is going to give me 5.5. What if I use this one here? I really like that one. Can I use that one? Not on the line. So you can find unit rates if I give you the numbers, or even if you have to find the numbers, because, hold on, you need two numbers to find a unit rate, right? Well, on a coordinate plane, you have an X and a Y, and that's two numbers. So you can even find a unit rate from a graph. 5.1 is due Friday. Don't forget about your chapter 5 openers. There is a work paper that you need to write the labels on for this homework. I'll see you guys later. Write your labels down.